Okay, we're going to begin our actual look into the unit of kinematics. Kinematics is the study of motion, and along inside of that is a bunch of terminology that we need to become very familiar with and have a clear understanding of. And so uniform motion is the beginning of this unit. And we look at speed or velocity, something that's moving, that's constant motion. But the key word here being uniform, meaning that it's constant. So we're going to start looking at vectors. And vectors are numbers that have a sense of direction with them. And so they could be a positive number or a negative number. And it could have north, east, south, or west. It could have forwards or backwards or up or down. It could have faster or slower. Descriptor words that tell us something about the value. Scalar values are only the magnitude. Magnitude is another word for a value. It's just simply the number. We don't need a direction to go with it. When we're looking at this displacement, we're going to be looking, in the past we've heard the word distance. And distance is the total movement that you've had. And so maybe you traveled 100 kilometers. It doesn't mean that it doesn't give us any information on the direction that you went. Maybe you went 50 kilometers south and then 50 kilometers north. In total, you traveled 100 kilometers. But displacement is the change in the distance and direction away from the reference point. And so if you traveled 50 kilometers north and then 50 kilometers south, you're right back at the same point where you started. Therefore, you have no displacement. And so we're going to be looking at both of these pieces. Distance, very specifically, is a scalar quantity. It has no direction. If I traveled 2 meters this way and 1 meter this way, I traveled 3.0 meters. It's the sum. So distance is indicated by the letter D. And so I would say D is equal to 3.0 meters. Displacement is a vector quantity. And if I traveled 2 meters this way and then 1 meter this way, what I'm going to find is that my distance with this little half arrow sitting over top of it, which means that this distance has direction. What I did was I went 2 meters to the left. And so when we have a positive or a negative number, we have a sense of direction. Positive is north, it's east, it's up, it's forward, it's right. And negative is south, west, down, backwards, left. And it comes from our quadrant. So this is a positive value and this is positive, whereas these are negative values. And so because I went 2 meters to the left and then I went 1 meter to the right, my displacement is negative 1.0 meters, which is a complete answer, or I went 1.0 meters to the left. And this is a much better way of reporting it. Do not say negative 1.0 meters left, because the left and the negative will counteract each other. So same thing with velocity. Velocity is a rate of change. It's indicated by v, again with a little arrow over top of it. And it's a rate. So that means that it's over time. And so what we need is displacement, because that's a change, over time. So velocity, again with that little arrow over top, and over time, I get incredibly lazy and I don't write that arrow in, but for now I do, is equal to a change in. A triangle means a change in. It's officially, the word is delta, but it means change in. So delta displacement over the change in time. And so then what we can write is we just write v is equal to displacement over time. So speed is velocity, only it's scalar. And by being scalar, there is no direction. Okay, so speed is equal to distance over time. And let's think about it. When you're driving down the road and you're heading from Fairview to Grand Prairie and the sign says 100, you're going 100 kilometers per hour. You're going 100 kilometers distance in 1 hour time. It doesn't say that we're going south to Grand Prairie. It doesn't say that we're going faster or slower. It just says that we're doing constant motion. And we show that using the exact same letters. V is equal to d over t. So speed is scalar. Velocity is speed with direction. I was going 100 kilometers per hour south. That's a velocity because now I have a direction. And that is shown by v is equal to d over t. And this is where we are going to get up close and personal with our data sheet. Here is our very first formula. V is equal to d over t. Okay, so let's look at an example. An object travels at uniform velocity. I'm going to show you these two words. Uniform velocity of 25.0 meters per second west. What is the displacement of the object after 10 minutes? Okay, uniform means that we're going to be looking at v is equal to d over t. Velocity means that it's a vector. It should have a direction. Here is our direction. This is something that I ask of you, and in the first unit I actually give you marks for it so that you ingrain the habit. Always write down the pieces that you know. So an object travels at a uniform velocity of 25 meters per second west. So velocity is 25.0 meters per second west. What is the displacement? What are we looking for of the object after 10.0 minutes? One of the things that we always need to pay attention to is units. Here, this is in seconds, and here This is in minutes. So this is why we spent a whole day reviewing unit analysis. We need to convert the 10 minutes into seconds. And so I'm going to start with what I know. I want seconds and I have minutes. In 1 minute, there is 60 seconds. So there is 600 seconds in 1 minute, in 10 minutes, sorry. Okay, the question is asking me what is the displacement of the object after 10 minutes. I know that in order to find displacement, I need this formula. It's asking me to find displacement, so I'm going to isolate that variable. The way that I do that, I multiply it by t. So my displacement is solved by taking my velocity and multiplying it by time. When I look at this closely, I can see that my seconds cancel out and I'm left with meters, which is what I know displacement to be measured in. And so my answer then is going to be now, this is where we spent also another class on learning significant digits. This has 1, 2, 3, and this one has 1, 2, 3. So our answer can only have 1, 2, 3 significant digits. Now I can't just write 150 because 150 is not 15,000. I need to put it into scientific notation. Knowing that this is my decimal point right here, and every time I make a jump, it's a factor of 10, 10, 100, 1,000, 10,000. I'm going to be 1.50, so I satisfy my 3 significant digits, times 10 to the 4, 1, 2, 3, 4, meters. Its displacement, this is something you should be in the habit of doing, is highlighting or underlining what it is the question is asking you for. Displacement means I need direction, so I'm going to put west in there. Okay, and then that would be your answer. You would get a half a mark for the 1.5 times 10 to the 4, and you would get a half a mark for the meters and the direction. And so sometimes we need to calculate average velocity. And so then we look at, and we write down here, V average is equal to displacement average over time total. Sorry, not average, total. Okay? And if we were looking for the average, this is going to be average velocity because our arrows indicate that we have direction. If I was looking for average speed, it would be my distance total over my time total. This is average speed. Let's look at another example. A runner goes for a run and ends up going 5.72 meters north and 2 meters south over a time interval of 3.75 seconds. Calculate the runner's average speed and calculate the runner's average velocity. Let's draw a picture so that we understand what's going on. The runner goes 5.72 meters north, and then he turns around and he comes back 2 meters south. Speed is scalar, is where the distance is the total. So if he goes 5.7 kilometers north And then he goes meters south. He went a total of 7.72 meters. That's the total distance. If it was velocity, it's displacement. And so he went 5.72 meters north, and then he went 2.0 meters south. And so he actually only covered 3.72. His position, I should say, only changed 3.72 meters. So very important pieces of information that you need to know. V is equal to D total over T total. So for speed, we have 5.72 plus 2.0 all over 3.75 seconds. We get a value of 2.0586. I'm going to round to 7. This is meters. These are seconds, so my unit is meters per second. When I look back at the original question, I have 1, 2, 3, 1, 2, 3, and 1, 2, 3. So my answer can only have 3. This 8 will play a factor. 2.06 meters per second is the speed that this runner traveled at. If I look at velocity average is equal to displacement total over time total, I'm going to have 5.72 meters minus 2.0 meters, because this one went north, this one went south, all divided by 3.75 seconds, because that's the total time it took. So 5.72 minus 2 divided by 3.75, 0.992 meters per second. Because 5.72 minus 2 leaves me with a positive value, my overall direction is north. Okay. Second question. In a high-speed chase, the felon is driving at 12 meters per second east for 7 minutes. He pulls on his emergency brake and does a complete 180-degree turn. He then proceeds to travel at 18 meters west for 15 minutes before arriving at his destination. Calculate the average speed of the vehicle and then calculate the average velocity. Well, let's draw a picture so we understand what's going on. He goes 12.0 meters per second east for a total of 7.0 minutes. And then he turns around, he does a 180, and he comes back, and he's going 15.0 meters per second for 15, he's going 18, sorry, my number's backwards, 15 minutes. That's what's happening. Information that we know, V1 is equal to 12.0 meters per second. Time 1 is equal to 7.0 minutes. Velocity 2 is equal to 18.0 meters per second. Time 2 is equal to 15 minutes. Some things that we need to change this minutes so that it matches the units in our velocity. So in 1 minute, there is 60 seconds. Seven times 60. Not sure why I used a calendar or a calculator. Seconds. This is 900 seconds. Okay. So velocity, it says calculate the average speed of the velocity. In order to do that, to calculate V average, we need distance total over time total. Well, when I look at my list here, I don't have distances. So I need to solve for distance 1 and distance 2. So distance 1 is going to be equal to V1 times T1, and distance 2 is going to be equal to V2 times T2. $540 meters, and then this one is 16200 meters. Okay, now I can go back and I can figure out my velocity because I have, or my speed, because I have my distances. So speed is scalar, so I'm just looking at the total distance that he covered and the total time that he covered it. And so that's going to look like this. And you can do it in the brackets, 540 plus 1620 divided by 420 plus 900. So I'm going to get 16.0909, and that looks like that's repeating. And then I'm going to calculate, before we go and do anything else, I'm going to calculate my velocity average is equal to my displacement over T total. And so he went in this 12, in distance 1, he went 500 or 5,040 meters to the right. So this is a positive value. And then he went 16,000 meters to the left. So that's a negative value. And then he still went 420 seconds one way and 900 seconds the other way. And you're probably like, why don't we put a negative 900? Time is linear. It doesn't matter that we go forwards and backwards. We can't subtract time. We can't take away time. So if you go 420 seconds to the right and you go 900 seconds to the left, that's time. We can't take away from it. So time is always going to be positive. And so we get negative 8.4545, and that looks like it's repeating. Our units are meters per second. Now we need to go back to the question, and here I have two significant digits 2 significant digits, 2, and 2. So my answers can only have 2 significant digits, which means that this 0 is what affects 16. So 16 meters per second is my average speed. And here, 2 significant digits, which means that 5 will play on the floor. And then paying attention to this value. He went 8.5 meters per second. And remember, back here, we said that if we got a negative value, we went south, west, down, backwards, left. And in here, because they used east and west, we're going to say west because that's what the negative value represents. Okay, you're going to stop it here and you're going to try these questions at the bottom of the page here in your question packet. And then when you're done that, we will go through the uniform motion review. Okay, looking at the review, Trevor is walking to school from home. He leaves and travels 58 meters before he forgets his lunch. He turns around, goes back home, and grabs his lunch. He then walks 236 meters before he gets to school. What is the distance Trevor traveled, and what is the displacement Trevor traveled? So let's draw a picture. Here's his house with its lovely window and its door and its chimney. And Trevor walks 58 meters. Remembered he needed his lunch, which means he walks 58 meters back this way. And then he walked 236 meters to school. And we have no chimneys because it's cold in our school. Okay, distance is the sum. And so he walked 58 meters, 58 meters, and 236 meters for a total of 352 meters. Displacement, we need direction. He walked 58 meters away from home. Then he walked 58 meters back home. Then he walked 58 meters away from home. And so he walked a total distance of 236 meters. And our unit is to school. Okay, a car travels at 100 kilometers per hour for 1.5 hours, heading east. However, there's an accident on the highway, so traffic is redirected. The car travels west for half an hour at a reduced speed of 60 kilometers per hour before the car reaches a secondary highway and gets rerouted. So what's the average speed and what's the average car? The car was heading east at 100 kilometers per hour for 1.5 hours. Hit an accident, turn around for half an hour, and they were going only 60 kilometers per hour because I imagine there's a lot of traffic on the road. Then they found another route. So it's asking us what is the average speed of the car and what is the average velocity of the car. always writing down the pieces of information that we know. V1 is 100 kilometers per hour, and T1 is 1.5 hours. V2 is 60 kilometers per hour, and T2 is equal to 0.5 hours. Notice I put the directions in because those were velocities. The question is asking us to calculate average speed, and we know that V average is equal to distance total over time total. And so when I look at this, I look at my list of what I know. I don't have distances. So I need to solve for distance 1 and distance 2. So distance is going to be equal to velocity times time. One of the other things that I need to pay attention to is that this unit is in hours and this unit is in hours. Therefore, I don't need to do any conversions. So I can go 100 kilometers per hour multiplied by 1.5 hours, because then my units cancel out and I'm left with kilometers. So distance 1 is equal to, oh, I did not need a calculator for this. And then D2 is going to be equal to it's equal to 30 kilometers per hour. So now we can go back. Now that we have distances, now we can solve our answer. So I've got 150 kilometers plus 30 kilometers divided by 1.5 hours plus 0.5 hours. And so on my calculator, I see that we have plus 30. And note how I'm using brackets. That's because I want all of this to then be divided by the total value of the denominator. And I get 90 kilometers per hour, because that's my units, kilometers per hour. My velocity average is equal to my displacement total divided by my time total. So my displacement total is, I went 100 kilometers. Remember, I wrote my directions in. I went 100 kilometers east, which is a positive direction, and then I went 30 kilometers west, which is a negative direction. Time cannot be subtracted. Well, I shouldn't say that. Time can't be taken away. There's a difference between the two. Time can't be taken away. So 100 minus 30 divided by 2 hours is 65 kilometers per hour. My number is a positive number, and so overall they were traveling 65 kilometers per hour east.